Ever wondered how machines learn to predict outcomes based on available data? How do they figure out the relationship between different variables? The answer lies in a fascinating process called gradient descent, used in linear regression. In the realm of machine learning, linear regression is a method that aims to find the best fit line for a set of data points. This line is represented by two parameters, m, the slope of the line, and c, the y-intercept. The goal is to tweak m and c in such a way that the line best represents the data points. But how to measure if the line is a good fit or not? This is where the cost function, specifically mean squared error, comes into play. It quantifies the difference between actual data points and the values predicted by our line. The smaller this difference, the better our line fits the data. Now picture this cost function as a hilly landscape. The aim is to find the lowest point in this landscape, which corresponds to the best values for m and ce. This is where gradient descent comes in. Gradient descent operates like a hiker who wants to reach the bottom of the hill. This hiker uses the slopes at the current position to decide the direction of the next step. These slopes are the partial derivatives of the cost function with respect to m and c. The size of the steps taken by the hiker is determined by the learning rate, also known as alpha. A larger step might help reach the bottom faster, but carries the risk of overshooting, while smaller steps, though precise, might take longer. At each step, the hiker recalculates the slopes for m and c, and updates their values by subtracting the product of the learning rate and their respective slopes. If the slope is negative, m increases, and if it's positive, m decreases. This process repeats until the hiker reaches the lowest point of the hill, meaning the best m and c values have been found. The entire process is iterative, adjusting m and c, until the algorithm converges to the values that minimize the cost function. So, in essence, gradient descent is like a hiker descending a hill, adjusting their steps based on the steepness of the slope, continuously tweaking their path until they reach the lowest point. That's the beauty of gradient descent in linear regression, a simple yet powerful concept that forms the backbone of many machine learning algorithms. And with that, we wrap up this exploration of gradient descent and its role in linear regression. The next time you come across a machine learning model making predictions, you'll know that it's probably using this fascinating process to learn from data.